Hi, my name is Jason Collins, and this video is about the reflection effect. The reflection effect involves an asymmetry in risk preferences in the gain and loss domains. When people make a risky choice related to gains, they are risk averse. They prefer a certain option with lower value than the expected value of the risky choice. When choosing an option in the loss domain, they become risk seeking. This phenomenon is called the reflection effect. Put simply, people typically prefer to lock in a sure gain rather than risk it for more, but will take risks to avoid a sure loss. The reflection effect might also be thought of as diminishing sensitivity to gains or losses in either direction. This contrasts with expected utility theory, where the pain of losses increases as they grow in size. The reflection effect explains the framing effects in this experiment by Kahneman and Tversky, 1984. One group of experimental subjects were asked the following hypothetical question that would be unlikely to be asked post-COVID-19. Imagine that the US is preparing for the outbreak of an unusual Asian disease, which is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the program are as follows. If program A is adopted, 200 people will be saved. If program B is adopted, there is a 1/3 probability that 600 people will be saved, and a 2/3 probability that no people will be saved. Which of the 2 programs would you prefer? 72% of participants choose option A. Another group of experimental participants was shown the following. Imagine that the US is preparing for the outbreak of an unusual Asian disease, which is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the programs are as follows. If program C is adopted, 400 people will die. If program D is adopted, there is a 1/3 probability that nobody will die and a 2/3 probability that 600 people will die. Which of the 2 programs would you favour? 22% of participants chose option C. Despite their differing presentation, these 2 scenarios are mathematically identical. Programs A and C both result in 200 people living and 400 dying. Similarly, programs B and D offer a 1 in 3 chance of saving everyone and a 2 in 3 chance of everyone dying. The difference is that the first scenario presents a gain frame, focused on lives saved. The second scenario presents a loss frame, focusing on lives lost. In the gain frame, 72% chose the certain option A over the risky option B. In the loss frame, only 22% chose the certain option C, meaning 78% preferred the risky option D. This shift in preferences demonstrates the reflection effect. When the choice is framed in terms of gains, lives saved, people prefer the certain option. When framed in terms of losses, lives lost, they prefer the risky option. The following value function is an example of a function with diminishing sensitivity to both gains and losses. This function generates the reflection effect. As x increases in magnitude in either direction, the marginal change in value from each incremental unit of x decreases. This decreasing marginal change is implemented via the power of 1/2. For the value of the gain or loss to double, the size of the gain or loss must quadruple. When x is less than 0, we apply a negative sign to x, as the power of 1/2 is only defined for positive numbers. We then apply another negative sign after applying the power to indicate the negative value of losses. This value function results in risk-averse behaviour in the gain domain and risk-seeking behaviour in the loss domain. This plot shows the diminishing effect in each direction. In the gain domain, the function is concave, indicating risk aversion. In the loss domain, the convex function indicates risk-seeking behaviour. The result is an S-shaped curve. The following numerical example illustrates further. Suppose an agent has a value function that expresses the reflection effect with the outcomes in either direction subject to a power of 1/2. The value of outcome x equals x to the half where x is greater than or equal to 0, and it equals negative minus x to the half where x is less than 0. The agent is offered a choice between $10 for certain and a 50-50 bet to win $20 or end up with nothing. We calculate the value of each option by substituting the outcomes into the value function. For the certain gain, we substitute $10 into the value function. The value of that certain gain equals the value of $10, which equals 10 to the power of 1/2, which equals 3.16. For the bet, we calculate the probability weighted value of the potential outcomes. The value of the bet is 0.5 times the value of 20 plus 0.5 times the value of 0. And we can calculate that equals 2.24. The $10 for certain has a higher value for the agent. This agent is risk averse in the gain domain and therefore prefers an amount for certain over a bet with the same expected value. The following chart illustrates. Plotted are the value of the certain payment of $10 and the outcome from winning the gamble, $20. A loss results in value of $0. The value of the gamble itself is the probability weighted average of the two gamble outcomes. Due to diminishing marginal utility in the gain domain, the value of the gamble is less than the value of $10 with certainty. The extra $10 over the certain outcome from winning the bet is less than the value of the first $10. As a result, the agent does not want to risk the bet. Suppose the agent is now offered another choice. They can now have a certain loss of $10 or a 50-50 bet to lose $20 or to lose nothing. Again, we calculate the value of each option by substituting the outcomes into the value function. For the certain loss, we substitute negative $10 into the value function. That value of that certain loss is the value of negative 10, which equals minus 10 to the half, which equals minus 3.16. For the bet, we calculate the probability weighted value of the potential outcomes. The value of the bet is 0.5 times the value of minus 20 plus 0.5 times the value of 0, which we can calculate to be minus 2.24. The bet delivers higher value than the certain loss, despite the bet and the certain loss having the same expected value. The agent is willing to take a risk to avoid a loss. They are risk-seeking in the loss domain. The following chart illustrates. Plotted are the value of the certain payment of negative $10 and the outcome from losing the gamble, minus $20. A win results in a value of 0. The value of the gamble itself is the probability weighted average of the two gamble outcomes. Due to diminishing marginal utility in the loss domain, the value of the gamble is greater than the value of minus $10 with certainty. The potential loss of another $10 over and above the certain loss is given less weight than the first $10. As a result, the agent wants to take the risk.